Hey guys, someone asked how to create a wispy smoke in Houdini, the wispy look, not the dynamics of it. So this is a quick attempt at creating that. Obviously the dynamics here are not the best, but we're looking at the look mainly. This is just a quick flipbook, and as you can see, it's already looking like a wispy smoke. So let's try creating this very quickly. Let's jump into Houdini and create a geometry node and jump in. And I'll cheat by doing the configure pyro below smoke, this one. Just start with this just as a base. Let's see here. And I'll just delete all of these below here. And I will actually change this torus to a sphere. And let's change the size of it to something like 1.5. And let's keep it as it is in here. I'll connect it in here. And it's a bit too big, so if it's going to be like a small cigarette, maybe we should reduce it in size a bit. I'll just do... Obviously, this is still too big, but it's at least a smaller scale. Maybe I'll change this in here to polygon, and I'll do a higher resolution in case I'll add some noise. But to begin with, I will just keep it as it is, like this. And we'll see the settings in here. Let's see. We already have a density and a temperature. That's good. And we have some velocity noise and a rasterization of the attributes to volume. Then we have the solver in here. And I'll just take a quick look and display this. I think we'll increase the resolution to something higher, like this. And I'll just increase my memory here while I'm deving in here. So let's go to the bounds. I think I need to change the bounds a bit. Yeah, it's not limited, so it's fine. I'll just increase the resizing in here to the padding to 1.5. And let's go to the other settings in here. I'll remove the flame. I don't need that. Let's go to shape. And obviously in here, I mean, you will have to do your own settings that fit your dynamics, the dynamics you need. So I'll leave that to you, but I'm just doing a quick version in here to just give us something. And it's an okay start to begin with, but let's just change it a bit. I'll increase the buoyancy in here to 0.4, so it's using more of the temperature that we're feeding in. So it's rising higher or faster. And I'll remove the wind. And in the disturbance in here, I'll just change a few settings. I'll remove the speed field that we're using in here. And I think we may have a bit too high of a disturbance, so I'll just leave that at 1 to begin with. And let's reset this threshold to the default. Cool. Let's go to turbulence. And I'd like to make the turbulence a bit higher, but smaller in size, so 0.5. And also I want it to be affecting not the lowest densities and not the highest, but something in the middle. So I'll remap this to a hill in here, so it's higher in the middle. Great. And I also want to add some viscosity, so it is blurring the shape a bit. So I'll just do 0.1 in here. Let's see how this looks quickly. I think we should add some velocities. So let's go to the pyro source in here and add another attribute, and I'll just do a velocity. And let's remove the Y and Z, and let's just keep it in the X, so it's flowing this way. And I'll increase this to 3. Let's take a look at the noise they've added here for us. And I'll remove this pre-processing, and I'll just lower the amplitude and potentially, yeah, also lower the size. We may want to actually add 2 of them, so let's just do a copy. Let's remove this first, and let's do a copy of this one and add it in here. We'll make this larger in size, and obviously it should be animated. I think this one is animated as well. Great. We could also add some noise to the temperature in here. So let's just add an adjust float, attribute adjust float, and let's just select the temperature, and let's add a noise, and we'll multiply that by the existing values. And I don't want the temperature to go to absolute 0, so let's just do 0.2 to 1. And I'll just animate the noise in here like this. Great, so let's take a look at this. See in here. Okay, it's something. I think we'll add some more turbulence, but we'll do it in a second layer. So let's just jump inside and let's add a turbulence, gas turbulence, and let's connect it into the force output in here. And I'll just do a scale of 1 in here and potentially, I think, a size of 2, something like that. And let's go to the control settings and enable the control field, and let's enable the remap. So we have amplitude mainly in the middle in here as a hill. I'll also add a vortex confinement, and I'll just merge it in here. This will also break some of these mushrooms, so let's give it a high value in here to 5. And let's take a look at what we have. Let's see. I think this is okay as a test bench, so you'll have to do your own dynamics that fits whatever you're going to use this on. I'll just reduce the amount of frames here to 48, so we're not working with a lot of frames. And I'll remove these boxes like this. And let's just go to the look in here. This is just for the look, so let's leave it as this. And let's go to advanced. And I'll remove this hourglass filtering. Let's see how this looks without. I think this is fine to work with for now. I'll go to the output in here and I'll remove the CD, the flame, and the temperature. I only need the density and the velocity. And let's remove these culling in here. And they use 16-bit, and let's remove the compute min and max, as that takes a bit of computing power. And so this is a base simulation of smoke, and we want to advect particles. This is a common way to get some finer sheets of smoke, but we'll do a bit of a twist in there to get it looking a bit more wispy. So I will create a pop simulation for these particles. So let's just drag this sphere to the side a bit, and I'll drag a line and add a scatter node. Let's look at the scatter. Oh, I'll just reset my viewport quickly. Let's go back. Let's see. All right, so that's the scatter. And it's very uniform right now, so I'll just open the parameters and I'll remove the relax iterations. And you'll have to be careful on how much you will add in here, because this will determine the speed of your next steps. So I'll just start with 1000 and we'll see how it goes. But I want to vary this a bit more. So let's just add an attribute adjust float. And I'll just I'll call this attribute density. And let's just add a noise, and let's change the ramp in here so it's mostly the high values. So I'll just lower this in amount. I'll select all of these and I'll do a B-spline. Let's do something like 0.9 in here. And I'll reduce the element size to 0.3. And we'll add a bit of animation with a pulse duration of 2. So if we go into the scatter now and look at the settings, we can enable density. And as you can see, this is changing based on time. I also want to change the seed of the scatter for each frame. So I'll do a $F like this. Great. So the idea here now is that we will use this smoke simulation to advect these particles based on the velocity of this simulation. So wherever the velocity here is going, we will push these particles. But what we want to do a bit differently than this regular setup of just advecting particles. We want these particles to be connected based on a spline. So for each frame, they will find where they started and where they are ending, and they will create a spline or a curve. And in order to know which one belongs to, which particle belongs to which particle, we need to just add an ID or an index. You can do that with an enumerate node. And I'll just change this to points, and that will give us the index in here. Great, so let's add a pop network, and I'll connect the second input to the pyro solver in here. And let's just take a look at this and go inside. Let's change the sourcing in here to be from the first input, and it should be all points. So right away we're getting points, but they're not doing anything. So let's add a pop advect by volumes, connect it in here, and let's select the second input, and I'll change the advection type to update velocity. Let's play this, and something is happening right away, but not quite right. I'll increase the blend of the velocity to 1, and I'll actually increase the overall velocity to 2. And let's change the advection method to trace. These are just better methods of tracing the velocity than the single step. Let's play this. Something's happening. And it might not look that good right now. But let's add the curves that I talked about. And in order to do that, let's add a SOP solver. And let's call this make into curves. And I'll connect it in here. And let's jump inside. And in here, we can add a node called add, which is very simple. And we can go to polygons and to connect the points by group in here. And it's a bit crazy right now, so we have to change this to by attribute. And let's write in index. But it's a bit crazy. So let's just reset the simulation and try again. So it's working, but the lines are getting stretched and they're not looking that great. So we need to resample this. So let's add a resample, connect it in here, and be careful how far you go down in resolution. I'll just do 0.2. I think for the test I did, that worked fine. So make sure you're not going too low on this amount, because that will increase the amount of points overall in the simulation. And I'll change the treat polygons as to subdivision curves. And let's see how this looks. And it's slower, as you can see, because it's adding for each frame the curves on top of each other. So what we need to do first is, so let's go to the frame in here. So we need to add an add node in here and connect it in here. And we need to remove the current geometry, the current curves, because we want to redraw them for each frame. So connect it in here. So this first add will remove the existing curves, and the second add will add again new curves. And this resample will resample the curves. So let's see how this looks. Let's try again. Play, and it's faster. And it's taking the shape of the simulation, which is great. But it's not quite looking right yet. And also, we created these, we resampled them, and this is kind of the important part. But we don't need to actually save the curves in the cache for this simulation. So if you want to cache this, you don't need to cache the curves. So you can add an add node here, and you can just remove these. And then later on, after your cache, you can add them again by using an add node. And let's remove this and go to polygons by group, and let's do by attributes and index. So you should be getting the same as what we had in here, which is great. And if you're going to save this to a cache in here, let's just pretend like we're going to cache this out in here, pop sim, and what I'd recommend is cleaning all your attributes because you don't need most of them. Let's remove this and remove unused points, and let's add a remove attributes and groups, and I'll actually keep the velocity and the index in here. And the velocity is a 32-bit attribute, and we can reduce the amount of data in that by just adding a cast node and casting this velocity attribute to a 16-bit float. That will save us some space in the storage. Great. Let's pretend like we save this and we're adding this back. We can add a resample again in here, and we'll do a resample the same as the one inside the solver, and we'll subdivide the curves so they're a bit more smooth. You can do a higher amount if you want, but don't go too far because the next step could be heavy. You may actually want to keep the age and life of the particles. And speaking of age and life, we want to determine how long they live, because if you have a long sim, this would be very heavy over time. So we want to kill some particles over time. I'll just do a life expectancy of 2. We only have 48 frames, so they will start dying after 2 seconds, which is 48 frames. So we would not see any dead particles, but just keep that in mind. Let's go back, and right now we have index, life, age, and velocity. You could also cast the life and age attributes to save some space. Great. So the method we want to use to make this into a wispy smoke is by using the volume rasterize hair node. And I'll just disconnect this for a second and look at the settings. And in here, you'll have to be careful with the width scale, because this is the scale of the curves, and the voxel size in here. And by default, it's calculating a color and a tangent field and a velocity field. I'm not going to use any of them, so I'm just going to deactivate this. And the velocity can be useful if you want to add some motion blur in the render later. But I'll just deactivate this. And let's connect it now. I'll reduce the width scale to something very low to begin with, and let's display it. And as you can see, something is happening, but it's very faint. So I'll increase the width scale. I'll just increase the display resolution of volumes in here to something higher, like this. Great. In order to get this looking more like a wispy smoke, we need to adjust the width or the p-scale. So let's add an attribute VOP and connect it in here. I'll just call this p-scale, and let's jump inside. And I want a p-scale based on the life of the particles. So we have a life and age in here. And you can get a normalized life or normalized age, which means a 0 to 1 value of when in the particle's life you are. And then we can use that to affect the p-scale. So let's use them. So to get the normalized age, you need to take the age and divide that by life in here. And we can just connect this to a p-scale. Before I do that, I will not display this volume rasterize, and I will add a bind export, and write p-scale in here. The reason why I'm doing that is when you give it a p-scale, it will change the scale of the curves in the rasterization, and that will make them very large and very heavy. So we'll have to deal with the next node in a bit. So now I'm taking the normalized age and I'm putting that into the p-scale. But I want to fit that a bit. So when the age, so when it's born until it's dead, that's the values in here. I want to take from, it's around 0. Let's say 75 in age to 1. And I will make that to 1 to 0. Which means when it's at 0.75 or less in its age, then it's 1. And when it's 1 in age, which is, you know, the maximum it will live, it will be 0. So it will fade out at the end. Great. So let's go back to the volume rasterization. And before displaying it, I will just highlight it and I will reduce the width scale in here to something very small to begin with. And I'll display it. And something's happening, which is good. I'll increase the voxel size in here to 0.01. So it's higher resolution. And I'll reduce the density scale in here to 0.25. And something is not quite right. Let's take a look again at the simulation. Let's go back to our pyro solver in here, and I'll actually not make this into a VDB. So it's not a VDB. And I think we need a lot more points in here in the scatter. So I'll just increase this to 5,000. But be careful, this can be very heavy. So I'll simulate this to, let's say, frame 30 and see. And let's take a look at the rasterization. And it's looking a bit better. And what we can do is we can add a bit of a contrast to this look. So first, let's just add a pyro bake. Display this, and you can choose a color if you want. Let's do something bluish or purple. And let's increase the value in here to 5. And before this pyro bake, let's add a volume bop. Connect it in here. And let's just call this contrast. And let's add a power node. Connect it into the density in here. And I'll just do something like 1.3 maybe. And that will give you a bit of a contrast in your smoke. Just to take a look at the pop sim, I think it's a bit, I think the smoke sim is a bit too slow. So I'll just increase the time scale in here to 1.5. And I'll try this again. Let's see at frame 30. But you get the idea. It's quite similar. You can go in here and increase the density if you wanted to make it a bit brighter. Yeah. Yeah, you can always go back and tweak whatever you want in here and see if it's better to what you want it to be, especially the shaping turbulences and disturbances in here and the velocities we've added before. And just like that, it worked. I just changed the pyro solver to add a bit of wind. So 1 in the speed and 1 in the X. And I just limited the sourcing in here. I just kept it at the default. But that should be it with the curve simulation to get it to look like a wispy smoke. And let's just go to the last frame in here to take a look. And that's looking good. Obviously, if you wanted to render this, you could just add this to the stage context. So let's just try that quickly. I'll copy this null and I'll go to the stage context. And I'll just do a SOP import. And I'll paste this in here. Let's just call this smoke. And it's hard to see. Let's change the background to dark. And it's here. Let's add a material. So material library. Display. Let's go inside. And I'll do a karma smoke material in here. I'll just call this smoke, and let's just go inside, and let's change the shader in here. Let's go to the density scale, and I'll just lower this to 0.5. And you can play around with the color. Let's just see how this looks first. I'll also fill the materials and assign to geometry, and this is called let's see, /smoke. There we go. And you can just add a quick camera. Let's just say around here. Let's see, new camera, and let's just add a karma render. Oh, it's fine. Let's display this. I'll remove the lock on the camera. Let's just test this quickly. And it's very dark. Let's go to the material and inside in here. And I'll remove the shadow just to 0.1. And let's do smoke brightness to 10. And I'll change the color. It's obviously too dark in here. Let's go with the bluish color we had. Maybe it's too blue, but you can change that. Something like this, and I'll just remove the grid in the background. And it's looking nice. Let's just increase the render settings. So samples to like something like 64. And maybe the resolution to 920. I can even add a dome light. And we can give it a texture HDRI. So let's just go to the default Houdini HDRIs. Let's just select one. And this is a bit too dark, but you can increase the exposure if you wanted. And if you don't want to see this background image, you can just go to display and you can go to display environment light as background. And that will get rid of the background for you, but it's still being used in the light. And that's a rendered Wispy smoke. Thank you for watching.